Good morning, guys. I hope you're doing well today. All right, so the time has come for our first test of the semester. As you can tell, we're moving a tad bit slower than we did in first semester. It took us quite a bit to get to our test here. We're like 4 weeks, I think. This is technically week 5, I want to say, into the semester. So we are moving a little bit slower, but we are dealing with some more kind of complicated issues, especially in the start of Unit 6, or when we got to some of the polar graphs and parametric equations and whatnot that took us a little bit longer. We are going to go ahead and review today for that, but before I do, I have an announcement about ACTs. Woohoo! I know you guys are all excited. Let me take a look here. I got a lot of juniors in here and a couple seniors. So my seniors, you guys are lucky you don't have to worry about this. But any juniors in here, you do have to take the ACTs next week, Tuesday, Wednesday. So they're finally coming up. They're a week away. Has everybody received information in the mail or in an email format regarding your ACTs for next week? Okay. Did you guys get your answer sheets yet? So I think you guys will be mailed answer sheets, and you have to fill that out ahead of time. Did those come? Did anybody get that? Yeah, the one you have to fill out before you get there? Okay, good. If you didn't get the answer sheet, my guess is it's probably going to be delivered today in the mail, since there wasn't any mail yesterday due to President's Day. So if you didn't get that answer sheet to fill out, hopefully you'll get that today in the mail. You want to make sure that you fill that out completely before you come to testing next week. If you guys have your graphing calculators, you can bring those, all right? Your graphing calculators are allowed in the ACT tests. All right, so if you're really familiar with them, I would bring it with you. Just make sure you have a new set of batteries in there, because it never fails. Right when you need that calculator the most, that little screen is going to pop up that says change your batteries. So make sure you got a good set of batteries in your calculator so they don't die on you at the worst time possible. Now, everything that's on the ACT as far as the math portion goes, you actually can solve it without any calculators. But you guys know shortcuts, you know graphs, you know how to find x-intercepts using your graphing calculators. You know how to find maximum and minimums. All of that can speed the process up, right? Obviously your tests are timed, so if you can use your calculator to speed the process up, you're going to want to do that. The other thing is we offered this last year to our juniors, so we're going to offer it out again. So I think Rachel and Isaiah can vouch for this. But if you come to ACT testing both days and you try on your test, meaning you don't leave anything blank, right, especially with those writing portions, we just don't write a sentence and stop. So if you show up both days and you try on the test, you will be emailed a Google form to fill out, and that basically will earn you a free final exam exemption pass at the end of the semester. So basically you get to choose which class you want to skip the final exam for. There are a couple guidelines though. You cannot do it for AP classes, right? So it doesn't work for AP courses. And you have to maintain a 70% or higher at the end of the semester in order to qualify for that one final exam exemption pass of your choice. Okay. Yeah, so and the second day of the ACTs, like Isaiah said, is going to seem easier compared to the first day. The second day is your work key days. The first day is the actual ACT day. So that second day is kind of the work keys. That's more of your real world type of things. and it's not going to be quite as complex, like Isaiah said, as that first set of testing on day 1 is going to be. At least that's kind of what people are noticing. So that second day, the worksheet days are more kind of elementary based. I don't even think elementary is a good way to put it. Yeah, it's a lot more common sense. Yeah. Okay. Are there any questions regarding the ACTs for next week? Obviously, we will not be having a live class on Tuesday because I'll be at testing myself. So Rachel and Isaiah, you kind of get a short break for the day next week, Tuesday and Wednesday, while the rest of us are all testing. So enjoy your day of freedom, or work on some of your other courses maybe, but you do get that day off while we're all testing. I figure you probably got some type of chemistry laying around you can work on. All right, great. And again, that final exam exemption pass, the teacher or the proctor at your site will email you the Google form to fill out after the ACT testing has wrapped up. So I would say by the end of next week, you'll probably see an email for a Google form to fill out regarding that final exam exemption pass. That's a tongue twister to say, final exam exemption pass. Free final exam exemption pass. I forgot the free. That's even more. More of a tongue twister for me. All right. Yeah, instead of having to actually pay for it, it's free. You don't even have to bribe me, right? That sounds kind of weird putting the free in front of it. No bribes required. That's right. Maybe Isaiah and Rachel will have to bribe since they're not taking the ACTs, but everybody else is free. Isaiah and Rachel, I do like candy. I have a very nice sweet tooth, so if you're looking for bribes, you know, just saying candy might work if you want to send that my way. Apparently candy is what the going rate is for the final exams these days. That's all it takes is a nice candy bar. Right. Okay, so for the rest of the class today, we're going to go ahead and study for that Unit 6 test just a little bit more. I think the test is prepared or on the calendar for tomorrow. Does that sound right, or is it on the calendar for today? Okay, today. I knew it was today or tomorrow. I get some of my classes mixed up. All right, so after today, I think you should be really good going into that Unit 6 test. We've had plenty of time to prepare. I mean, we looked at those difficult homework questions last week. We'll review some of those earlier concepts here this morning. And then I think you should be good to go for that test either today or tomorrow whenever you have scheduled to take that. Well, there you go. That works. I mean, leftover Valentine's candy, I'm not above like clearance candy, by the way, either. So maybe keep that in mind after Easter wraps up too. Peeps are a favorite. So if you see any clearance Peeps, that's always a bonus in my book. There you go. All right, so I was actually playing a game Kahoot with a class yesterday, and we looked, and there is a free Kahoot app for smartphones. So if you have a smartphone and you want to download the Kahoot app really quick, it is free, like I said. And you can hold kind of your phone in your hand and look at the screen at the same time, and then just choose the colored box you want from your phone versus having to switch back and forth on the computer screen. Yeah, so if you have a smartphone that, I mean, obviously you want parents' permission, but the Kahoot app is not anything that's going to compromise anything on your phone, give you any viruses or whatnot. It's just the Kahoot colors, basically. So if you want to save yourself a little bit of time, you can go ahead and download that and play from your phone. In fact, I'm going to join you guys this morning from my phone and play along with you. So we're going to make it a competition. Who can win here, me or you guys? Everybody likes a friendly competition at 9 o'clock in the morning, right? All right, can you see the screen to enter the Kahoot game? Well, that's going to be a problem, isn't it? Let's see if it works this time. Did it go or no? All right, I have an idea. I think it's because I had an alternate program going. I think it should be working now. All right, problem solved. Yes, yep. I hope so, because I got a calculator and a notebook ready to go myself. So even though I made the Kahoot, doesn't mean I remember the answers that go along with the questions. So I'm going to have to work them out just like you guys will be. So we'll see who is faster here. I have to admit, yesterday I stumbled on a few. I get a little bit nervous, so you guys have a really good chance here. Okay, do we got everybody? We might be missing someone. Let's see who we're missing. Charter, are you in here? Well, I'll keep the game pin and we'll get started here. So if Charter can find his way in, that's awesome. Okay, I see the 1 sec there, so we'll give you a few moments here still. If you guys will have a calculator handy, I would grab a calculator. We might have to switch back and forth with our modes, so just kind of keep an eye on that with some of the questions. All right, there we go. All right. Whew. It's on. Oh, component form and magnitude even. Ah, okay. Woohoo! All right, let's see. It was in fact blue. Remember when we are doing the component form, you have to take a look at the letters here, P minus Q, so it's head minus tails. This, or head minus tail rule there. So you want to start with the Q and subtract off the P. So we want to do the 6 minus 5 and the 9 minus 8. So you kind of do that tails minus head, maybe it's called. I can't remember which format it was, but you take the ending point and subtract off that starting point. So we do want to get the positive one versus the negative aspect of that. We did get the magnitude right though, so everybody got that correct because we want to square both components there, add them together under the square root sign. So we got that going for us, which is awesome. All right, I'm in lead, but Charter is right up there. Then Callie, Tommy, and Isaias is rounding out our leaderboard. So, okay, either Bruce Springsteen's in here or I got a really good name here. Let's go ahead and take a look at question 2. All right, we're adding things together now, it looks like. Whew, we were nice and fast that time. Yep, we do want to add, so -3 plus 8 is 5, 4 plus 2 is 6. All right, Tommy, oh, Tommy's right there. Then Callie, Charter, and Rebecca round out the leaderboard. Yeeks. All right, let's see the next question. My reflexes are a little bit slow, so you guys take it easy on me. Yay! All right, nice job there. So again, we're just multiplying by those scalars and adding the two vectors together. We should end up with the 15, -21 there. Oh, I was really nervous because I was not the first one to log in that time. I heard a click before me, so I was really nervous with that leaderboard and how it's going to shake out. Again, Tommy's really close. Callie's creeping up there, and then Rebecca and Isaiah. So still kind of anybody's game. We got lots of questions to go. It looks like we're looking for maybe the dot product there. All right, so dot product, we do want to be careful because we can't actually multiply vectors together, right? We can only perform scalar multiplication, and that's when you multiply a constant through a vector. You can't actually multiply two vectors together. So when you see the little dot here on your test, make sure you know that that's denoting the dot product of your two vectors. So the dot product, remember, is we're going to multiply each component together. So we'll multiply the i's. So 4 times 4 is 16. Multiply the j's to get a negative 20, and you add those. So 16 minus 20 is our negative 4. All right, gained a little bit of ground there over some of the field, although Tommy is right there still. Callie, Isaias, and Rebecca round off the leaderboard. Take a look at the next question. Find the angle between the vectors. Oh, goodness. All right, so I admit I blanked on the formula for the angle between two vectors. I had to look it up. So it definitely was not the fastest there by any means. But the angle between the vector, we have to do cosine of theta equals the dot product of our vectors over the magnitude of each vector. Okay, oopsie. Was typing and it disappeared. So you actually have to end up doing the cosine inverse of that dot product over the magnitude of the two vectors there. When you do that, you should get 1.8 degrees. I second guessed my answer myself because I didn't think I was in degrees versus radians. You want to make sure you're in degree mode there as well to get that 1.7899. All right, so that was a tricky one. We have some change in the leaderboard though. Well, maybe we don't have change in the leaderboard, but definitely some advancement on our numbers there. All right, that one was a tricky one. We went kind of back in the books for that one, back to lesson 6.02. All right, let's see what's in store for us next. The vectors are parallel, orthogonal, or neither. All right, they are in fact orthogonal. Yeah, it doesn't really spur my best work either. So I still feel the pressures of the time of the clock, just like you guys. All right, they are orthogonal. When we do the dot product, essentially, we are looking to see if we get 0. So if you do get 0 with the dot product, we know that they are orthogonal, which means perpendicular. If you notice that one of your vectors is a scalar multiple of another, meaning you just multiplied through by a constant, then we know that's when they're parallel, right? So if that would have been like 6, 12, and -2, -4, we can see that that second vector is just a multiple of the first. That's when we know that we have parallel vectors occurring. If neither of those are the cases, you don't have a multiple of a vector and you don't get 0 for your dot product, then we know that neither is occurring. All right. Ooh, I gained a little bit of lead on the field. I still think it's possible to catch me though, so don't give up quite yet. Ooh, this time we're looking at R, V, and W. And we just want the dot product of V and W, it looks like. The music doesn't help either, does it? All right, so this one we actually have like a 3-dimensional vector occurring here. We will be looking at 3-dimensional vectors and coordinate planes in the next, no, not in the next unit, in Unit 8. I take that back. So in Unit 8, we will actually be looking at more 3-dimensional things there as well. But the process is just the same with 3 dimensions as it is with 2. You just have an extra multiplication and addition piece occurring. The blue is actually set up as the multiples of each component, so 3 times 6, 4 times -9, and 7 times 7. But with that blue answer, you needed to add each component together to get the 31 then. So let's go ahead and take a look. Ooh, Rebecca's catching up. She had a nice jump there, but Tommy is not far behind Rebecca by any means. So only about 2,000 points separate us. I'm trying not to use my calculator to slow down my advantage a little bit, so you guys have a good chance at catching me here because I'm going to be working without a calculator for the most part. All right, express a complex number in trigonometric form. So we just took a look at this the other day. In fact, this exact question, I think. All right, did you guys guess blue? So blue is the correct answer there. Now, I did this one without a calculator, thinking of where the point 0 minus 3i would fall in my complex plane. So remember the 0 and then minus 3i is relating to that point of 0, negative 3. So 0, negative 3 on the complex plane falls on that lower y-axis. So the lower y-axis, when I think about my unit circle, is 270 degrees. So technically I didn't need to use my calculator at all to figure out what that degree was going to be for my theta inside my parentheses there. So I kind of visualized that complex plane and where that number was going to fall to help me identify what the degrees was going to be in that trigonometric form. The R value, remember, that is just kind of your magnitude from that complex number. So 0 squared plus negative 3 squared is going to be the square root of 9, which is just the 3 out front. But every option had the 3 out front there. All right. Tommy's gaining on me, so I have well, I got a little bit over a 2,000 lead here, but Tommy took the lead over Rebecca again, it looks like, but Isaias and Callie are right there too. Ick, yeah, cosine always comes first. Ooh, I got that one wrong, only because I guessed on my theta there. All right, so all of us got it wrong. So the blue is the correct answer there. I was able to get my magnitude to be 6. We didn't have an imaginary I in this complex number, but we knew that that was your complex form because of that 3 square root 3 component, and this was the real part of it. So to find the magnitude, we wanted to take negative 3 squared, which is 9, and add this to the square of 3 square root 3, which is technically 9 times 3 to get a 27. So 27 plus 9 was a 36. The square root of 36 was 6. The second part was finding what theta was going to be. I did tangent inverse of b over a, so 3 square root 3 over negative 3. And on my calculator when I did that, I got a negative 60 degrees. And that's where I might have got my translation wrong. I accidentally chose 5 pi over 6 versus a 2 pi over 3 for that. So I wasn't able to convert that to my radians in the time allotted So I took a guess between blue or green and chose wrong. So maybe I'll take the time right now just to convert that and make sure that 2 pi over 3 is the correct answer there. I still think it might be a 5 pi. Well, I get a 5 pi over 3 instead of a 2 pi over 3 there. So we'll have to check. Yeah, you have to bounce it back into the second quadrant. Oh, that's right. Yep, we are bouncing it back into the second quadrant because that negative 60, you're right, falls into quadrant 4, right? But we don't want quadrant 4. We want quadrant 2. So we got to bounce that back around. I missed that part. Thank you, Isaias. So we missed that bouncing back piece to find the correct theta. So the appropriate theta there would be the 2 pi over 3 for that component in quadrant 2, because that is where that complex number is falling. It's falling into quadrant 2, not quadrant 4. So I had to adjust my theta for that, and that's the component that I missed of it all. So we would want that 2 pi over 3 because that falls into quadrant 2, not 5 pi over 6, which is, I think, in quadrant 4. Yeah, that's exactly what happened. So we shouldn't see much change in the leaderboard there since nobody got that one correct. So let's take a look at the next question here. All right. So that one is going to be your green. So essentially, we needed that unit circle to help us out here to find that cosine of 150 and sine of 150. The point at 150 degrees is negative square root 3 over 2 and 1/2. So starting with the cosine, 5/2 times your negative square root 3 over 2 does give you this negative 5 square root 3 over 4. And then the second piece of that, 5/2 times 1/2 is a 5/4. So we do want to go with green there. All right, let's take a look at the leaderboard. So Tommy's still sitting there in first, then Rebecca, Isaias, and Callie. Got a little bit of lead on you guys at 9,914. We can squeeze in a few more here, though. Eliminate the parameter. Okay, it's been a while since we've done our parametric equations. I may have made a calculation error here. We'll see. So when I didn't see a correct answer. I chose the blue though because when I did it mathematically, I actually got an x minus 2 in the denominator. So I'm guessing when I made the test, I probably had a typo with that plus or minus sign in the denominator there. I chose the blue because it had the 2 there, and that's the only one that did. So, but when I did that mathematically, I did get an x minus 2 in my denominator instead of x plus 2. Is that what you guys got as well? Yeah, so I think there was an error there, but the blue was the next best choice, so I'll have to go in and fix that one before next year. All right, so not much change with the leaderboard there. Do you guys want to quit or do you want to do one more? Because it's at 9:45, so we can either do one more or we can call it good. One more. All right, one more to win it all. Don't blow it. Oh no. Okay. Polar coordinates. All right, so there's the formulas we want to use to go from polar coordinates to rectangular. X equals r times cosine theta, and then x equals r times sine theta. Remember your polar coordinates are r comma theta. So punching those into our calculator, we should get that -7/2, and then that 7 square root 3 over 2. I definitely don't think I was first to punch that one in. I also guessed on that y because I got a 6.06 as a decimal on my calculator. And I was like, oh no, which one is that? So I took a guess and guessed correctly. So nice job there. Tommy came in first, then Rebecca, Isaias, and Callie. So nice job, guys. It was a good review for us. A couple things to maybe look back on there regarding our vectors and our angles between vectors and projection of vectors onto each other. So a couple things to maybe keep in mind and review before you get to that test today. But hopefully you feel pretty comfortable with that. You did a nice job here. We freshened up on some of those earlier topics, which is always a good thing. Are there any last minute questions then before I let you go today?